Hey everyone, Mr. Allen. Just going to go through the idea of a normal distribution. So the first thing to understand is provided we have a large enough group, a large enough sample or a large enough population, and we have a naturally occurring situation. Okay, so here were the examples that are given, marks, heights, weights, and so on. So these are things that will occur naturally, they're not being controlled at all. That if we have a large enough sample, we should be able to see kind of this sort of a distribution where there are few members of the population that have extremely small whatever it is, heights, weights, and so on, a few that have extremely large, again, heights, weights, whatever, and that the majority of the population, be it human population, animal population, vegetation, whatever it happens to be, will be somewhere in the middle. So the classic example is, of course, if you look at the heights of a group of people, here's a sample here, that there should be few people that are on the extremes in both cases. So the pink here is the women, very few women over 75 inches tall, very few under 55 inches tall, and that the majority would be in the 65 range, 62, 68 sort of thing. The men is the blue here, and same sort of idea. There is a fairly significant number in the range of approximately 70 inches, or again, 70 inches plus or minus 2 or 3 inches. And then as you get out to the 80 and so on, far fewer people. I just found these on the internet with a simple Google search, but this is the same sort of information in centimeters, and the values match up, so I'm guessing it's fairly accurate. The key to understanding, though, is that even though we draw the normal distribution as a nice smooth curve, it comes from something more like this. So the idea is that if we've graphed the entire population in some sort of a histogram, that we have this general idea of this basic shape. Again, in this diagram, assuming this is actually legitimate information, you can see that the number of women in the one group happens to be excessively high, but that overall, small, bigger, 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 a largest group sort of here in the middle, where the mean, median, and the mode just slightly above, in this case, happens to be. And then as we sort of look at the higher, taller and taller people, then we're finding fewer and fewer of them are women. The men, of course, is sort of slightly taller overall, a little bit more normally distributed. I don't know exactly where this information came from, whether it's sort of how big the population is, but you still have that sort of that general shape at this point. So the idea is that knowing that, we can use that information to make approximations. And sort of the information here kind of fits with this diagram. The majority of people, about 2/3 of people, 68%, are within one standard deviation of the mean. 95% are within 2 standard deviations, and then at the extremes are those 3 standard deviations where very, very few people, in fact 0.3% of the population approximately again, are beyond that 3 standard deviations. And so if we look at a specific question here, let's say the mean of a high school is 172 centimeters, and the standard deviation is this. So again, standard deviation, for anybody who doesn't quite remember, standard deviation is the sort of the average amount that people are off the mean. So on average, people are about 5.5 centimeters, sort of plus or minus 5.5 centimeters on top of this. So going back to the previous graph, that means that about, again, 2/3 of the population, or 68%, would be 172 plus or minus that 0.5. So somewhere in the 166.5 to 177.5 range is the vast majority of the people in the school. And the question is, what percentage of the school would be shorter than the 180 centimeters? So the formula given to us is just this simple, I'll say relatively simple, z-scores equals. And for anybody who didn't quite catch this part, the z-score is the x value is the specific value I'm talking about. So in this case, it's the 180 minus the mean, so the 172, divided by the standard deviation. So it's basically take the value I'm interested in, subtract the mean, and divide that by the number of standard deviations, or sorry, the size of the standard deviation, to essentially find how many standard deviations we are off. The math pretty simple at that point, once at 145. But I think what some people also missed is the idea that we have to then go to a z-score chart here. I don't know if it's open. And the chart itself just allows me to look up values to determine sort of those percentiles. So the number I had in this question, 145, I'm just looking on the chart down the Z line here. I have 0, 1.4. And then if I look across the top, this would be sort of the 0.01s, 0.02s. So 1.4 going across to right here is the 1.4 and then the 0.05 on there, 0.92647. Okay, so that's where this number has come from. And then what that says is that approximately or almost 93% of the students will be shorter than that value. Okay, so kind of going back to this concept, if we look at, this is a diagram that's sort of skewed towards that high school student or those high school students, the 172 is the mean, and we're really asking sort of where is this 180? So it's somewhere in this neighborhood here. And what they're saying is that if we count up all the number of students represented by this histogram up to essentially this point here, so essentially this area underneath the curve is representative of 93% of the population of this school specifically. And so again, one person that is or anybody that is 180 centimeters tall is taller than all of these people, which is to say essentially taller than approximately 93% of the people in the school. Okay, so sort of key concepts again, how a normal distribution looks, of course, the fact that it's representing an approximation of a histogram where the actual population has been counted up, tallied, and a frequency histogram sort of combination has been built to visualize the entire population. And then the value we're always looking for is where does that person fit in the percentile of the entire group? So what percentage of the population is he or she or it larger than? And then that's the value, of course, that we pull off of our z-score chart. And again, to use it, we simply go to the first two numbers that we found. In this case, it was 1.4. And then we find the third value across the top, the 0.05. And where do those two values meet? Right in here. So hopefully that helps a little bit. It's not, once we have the idea, the math certainly isn't going to be super tough, but it is important that we understand that's where it's coming from, and that's what the question's asking us so that we can actually solve them.